Om Swastyastu, Assalamualaikum Warahmatullahi Wabarakatuh, Syallom, Namo Budaya, and good to see you all. Now I will next my presentation is about metallurgy in the chapter non-ferrous metal, a variety of possibilities. And my name is Imade Yudhishthira Santya, and I have university code is 2305531063, and our lecture is Professor Dr. Chokoda Gede Teten India ST MTMN. In this matter, we have a metallurgy with a code TM2301. I'm from Mechanical Engineering Technical Faculty, Udayana University. And in this presentation, I take my main reference from the module is the metallurgy for the non-metallurgy second edition, edited by Arthur Cyril. And this chapter we have 10 sub-chapter. The first is light metal, aluminum, PEMGTI, corrosion resistant alloy, COCUNITI, and aluminum super alloys, refractory metals, FONB, RETAW, low melting point metals, BI, and PP, SN, Z, and reactive metals, BEHF, NBTA, TI, and ZR, precious metals, rare earth metals, metalloids, semi-metals, and the last one is special purpose metals and alloys. For the first, non-ferrous metals are very possible. Compared with their steel counterparts, non-ferrous metals and alloy are notable in their number and in the diversity of their properties. Many non-ferrous elements do double duty as important alloy agents for both steel and non-ferrous metals. The latter approach was chosen in this chapter, where several non-ferrous metals are grouped into the following key alloy categories: light metal, aluminum, beryllium, magnesium, and titanium, corrosion resistance alloys, cobalt, copper, nickel, titanium, aluminum, superalloys, nickel, cobalt, iron, nickel, refractory metals, molybdenum, niobium, rhenium, tantalum, and tungsten, low melting point metals, bismuth, indium, lead, tin, zinc, reactive metals, hafnium, titanium, and zirconium, precious metals, rare earth metals, and semi-metals which have their own specific. The light metals is high-strength lightweight alloys are of great importance in engineering application for use in a land, sea, air, and space transportation. 1 kilogram is 2.2 lb of metal saved in the design and construction of such a system can result in important weight saving in power plants, transmission system, and in total fuel requirement. So, like we can see in here, the magnesium with the gram per centimeter cubic density with 1.74 in the lb per in cubic is 0.06. The modulus of elasticity GPA is 44.8 and 10.6 psi is 6.5. And this aluminum, as a light metal, aluminum has a density of only 2.7 gram per centimeter cubic with a specific 0.1 lb per in cubic, resulting in a weight that is approximately 1/3 that of the same volume of steel, copper, or brass. Beryllium Be is a high-strength lightweight metal that is finding increasing use as a structural materials is aerospace vehicles. Magnesium Mg has long been recognized as the light structural metals, and the titanium Ti is another low-density element, approximately 60% of the density of steel. that can be readily strengthened by alloying and deformation processing. In the corrosion-resistant alloys, non-ferrous metal and alloy are widely used in corrosive environments. At one end of the spectrum, they are used for water piping and food preparation. And the cobalt CO is used as an alloying element in alloys for various applications such as permanent and soft magnetic materials, superalloys for creep resistance at high temperature, hard surfacing and wear-resistant alloys, corrosion-resistant alloys, high-speed steel, tool steel, and other steel, cobalt-based tool materials, e.g. the matrix of cemented carbide tool materials, electrical resistant alloys, high-temperature spring and bearing alloys, magnetostrictive alloys, special expensive contraction modulus alloys, and another. In the copper, Cu, and the copper tin alloys, bronze have an important application since antiquity. Copper is noble metal, but unlike gold and other precious metals, can be attacked by common regions and environments. Another passive state can be obtained when the metal potential is shifted to more positive values, forming copper oxide (CuO), as seen on the Purbach's potential pH diagrams of copper in the water. So, like in here, this is the diagram of copper in the water with a similar pH from the potential is the V. In the nickel and I, alloys are very important to industries that deal with aggressive chemicals and high temperature conditions. Many of the nickel alloys designed to resist aqueous corrosion progress higher resistance to hydrologic, hydroloric acid, and chloride-induced phenomena like pitting, crayfish attack, and SCC than the stainless steel. And the titanium Ti and its alloy are part of the large family of the material known as the reactive metals, and the aluminum, Al, like titanium aluminum, and its alloys are protected from many potential corrosive environments by oxide films that form readily on freshly exposed surface. And the superalloy are a group of the nickel-based, cobalt-based, and iron-nickel-based alloys that exhibit outstanding strength and surface stability at the temperature up to 85% of their melting points, Gm expressed in degrees Kelvin, 0.85 Tm Kelvin. And the nickel superalloys, nickel-based superalloys currently constitute over 50% of the weight of advanced aircraft engines. Turbine, these components are major application. Powder metallurgy processing of superalloys has proven to be very repeatable and cost-effective method of production. And the cobalt superalloys, factorily, all cobalt-based superalloys are alloyed with nickel in order to stabilize the FCC structure between room temperature and the solidus temperature of the alloys. Next we go to the refractory metals. This family has 5 members: niobium, also referred to as columbium, tantalum, molybdenum, tungsten, and rhenium. With the exception of 2 platinum group metals, osmium and indium, refractory metals have the highest melting temperature of the metals. Molybdenum has a relative high melting temperature of 2610 degrees Celsius is 4,730 degrees Fahrenheit, along with a high modulus, good creep strength, and the retention of mechanical properties at high temperatures. And niobium, in addition to its high melting point, niobium is used for its combination of relative lightweight and retention of high strength at the surface temperature ranging from 9,980 to 1,205 degrees Celsius. It's like 1,800 to 2,200 degrees Fahrenheit. Rhenium Re. The properties of rhenium are generally similar to those molybdenum and tungsten. Its melting temperature of 3,180 degrees Celsius is like 5,756 degrees Fahrenheit is the second highest among the refractory metals, and the tantalum Ca has a melting point of 209,096 degrees Celsius, which is like 5,425 degrees Fahrenheit, and high resistance to corrosion, including corrosion in body fluids. And the tungsten with the W, an extremely dense metal, is an excellent alloying agent. The major use of tungsten is in cement and carbide metal cutting tools and wear-resistant materials. The low melting point metals. Bismuth, Bi, is brittle, easy to cast, and not readily formed by standard working methods. It is melting point of 183 degrees Celsius. It's like 3,060 degrees Fahrenheit is lower than that of thin lead solders. Indium, In, is one of the softest metals, easily scratched and highly plastic. It can be deformed in compression almost without limit. It melts at 156.2 degrees Celsius or 330.1 degrees Fahrenheit, has low tensile strength and hardness, and is stable in dry air at room temperature. Lead or Pp. The properties of lead: high density, low melting point, corrosion resistance, malleability, unusual electrical properties, and the ability to form useful alloys and the chemical compounds combined with its readily available forms and relative low cost make it a unique material for solving a variety of problems. And the tin with the Sn, one of the first metals known to humans, is non-toxic, soft and pliable, and suitable for cold rolling. Tin resists corrosion, making it an ideal coating for other metals. And the zinc has a relatively low melting point of 419 degrees Celsius, which is like 787 degrees Fahrenheit. Resists corrosion, is ductile and malleable, and is highly soluble in copper. As a coating, zinc provides corrosion protection for iron and steel. And the reactive metals. Reactive metals readily combine with oxygen at elevated temperatures to form very stable oxides. Reactive metals are extremely noble because of their passive films. However, they may become embrittled by the interstitial absorption of oxygen, hydrogen, and nitrogen. And beryllium, titanium, niobium, tantalum, hafnium, and zirconium are considered reactive metals. Of these metals, beryllium and titanium are low-density metals and are often used for alloy and like structural application, as previously noted. For alloys, the primary application of zirconium is in the construction of nuclear reactor, generally as cladding and for structural element. And the precious metals is a gold, silver, and platinum group metals. Gold is extremely soft, ductile, and easy to deform. Chemically pure gold is 99.9% pure, and higher purity is commercially available. And silver among metals, pure silver has the highest thermal and electrical conductivity. Next to gold, it is the most ductile. Silver is one of the most common corrosion-resistant metals. And the platinum blue metals are expensive and scarce. The main deposits are primarily located in the Republic of South Africa. And the rare earth metals, the term rare earth is deceptive. Rare earths are not necessarily rare. The name derives from oxide minerals in which they are discovered. The family tree has this member is scandium, lanthanum, praseodymium, promethium, europium, terbium, holmium, thulium, lutetium, yttrium, cerium, neodymium, samarium, gadolinium, dysprosium, erbium, and ytterbium. Representative properties. Some rare earth can be fabricated cold. All are poor conductor or electricity and are paramagnetic, have a little mutual magnetic attraction. And representative uses. Rare earth metals are used in coated carbons for art, lighting. Mixed metal iron alloys serve as flint for lighter glass and a polish with cerium oxide. Metalloids. Silicon Si used in industry can be classified into metallurgical and semiconductor grades. Metallurgical grade silicon is produced by the reduction of sand, SiO2, in an electrical arc furnace. Gallium, A. The chemical properties of gallium are between those of aluminum and indium, and like this element, gallium is considered to be not toxic substance. Its melting point is 29.78 degrees Celsius. In the Fahrenheit is 85.6 degrees. Surface the temperature are increased by alloying. Like aluminum, gallium forms an oxide film on its surface when exposed to air. Germanium, Ge, is hard metallic element with a lower melting point. It's plus or minus 937 or 1 degree Celsius or 1718 plus minus 2 degrees Fahrenheit than silicon, which result in better fabrication properties. Below 600 degrees Celsius, 1110 degrees Fahrenheit, germanium has good resistance to oxidation. Above the temperature, oxidation proceeds rapidly. And the special purpose metal and alloys. Uranium is a moderately strong and ductile metal that can be cast formed and welded by a variety of standard methods. And the vanadium V, the melting point is vanadium is 1900 plus minus 25 degrees Celsius with the 3450 plus minus 50 degrees Fahrenheit. And the magnetic alloys, magnetic material are broadly classified into two groups with either hard or soft magnetic characteristics. And the electrical contact materials. Electrical contacts are metal devices that make and break electrical circuits. Contacts are made of elements, metals, composites, or alloys. They are made by the melt cast method or manufactured by powder metallurgy (PM) process. And there is the thermocouple materials, low expansion alloys, submetallic alloys, fusible alloys. Thank you for watching my presentation. I'm so sorry if there are any problems with my speak or something else. And good to see you all. Bye.